Okay, morning class. So, your test one will be in week 7 after your Chinese New Year break. Usually we'll use the 2 hour slot lah. So your 2 hour slot will be Monday. Okay, so right after your comeback, your Chinese New Year break, you will be your test one. This one will be the 2 hours. 2 hour slot. Okay, recall what we learned yesterday class. Yesterday we learned about 3 Newton law, right? Do you remember what is 3 Newton law? First one is what? Do you remember? Okay, so means an object will continue to move or stop or remain static unless there is a force acting on it, right? So that's one. Second one, second Newton law. What is second Newton law? Yeah, F equal to ma. So this one, make sure you make a good friend with this formula. This formula will be useful when it comes to dynamics. Static, not so much. When it comes to dynamic, then this one is very useful. The third one. Okay. Third one is what? This one, you deal with force also. This force, we talk about reaction. Right? So we talk about reaction. So if you give it a force, there's a reaction force. Okay. Sit force if there is something. This one usually or internal forces. This one. So this one is a 3 Newton law. It's important. Yeah. So basically that. Then your lab session. Your lab session will be conducted by after Reza. Okay. Okay, so your test 1, test 2, final exam will follow these 4 learning outcomes. Follow these 4 learning outcomes. So your test 1, which is after your Chinese New Year break, will you'll be seeing CL1 question, CLO2 question. Right? Yeah. Okay. So yeah, very high chances we look at internal force. We will be the third Newton law. Newton law. This one, equilibrium. Solve problem using equilibrium. Okay. Yeah. And then yesterday we mentioned one very important concept. What is the main difference between static and dynamics? What is the main things that separate statics and dynamics? What's the main difference between two? Velocity. In static, velocity constant. So in dynamic, velocity no longer constant. It can be constant, but most of the time it won't be constant when it comes to dynamics. So static is constant. So you know that velocity. You know that velocity definition is you take displacement divided by time. Not divided. Sorry, time differential of time. Okay. So and then yesterday we also cover what is scalar, what is vector. Okay. Scalar is magnitude, vector have two things. You have magnitude and direction, which is theta. Most of the time, we need to find this one and this one. Okay, scalar is just a magnitude, right? So it's a magnitude. Right. Okay. Okay. So basic quantity, length times mass. 32. Force is the idealization, means the way we solve problems. In statics, we will look into particles and rigid body. So again, what is rigid body? Rigid body is a combination of many particles. Right. Okay. So 3 Newton law. Okay. Now today we look at prefix. So this one you should already familiar lah. Okay. So popular one is mega, giga, kilo, deci, centi, milli, micro, nano. These are the most popular one. We rarely ask you something in this. Okay. And important is the scientific index here, right? So this is to simplify your calculation. All right. Next, we look at direction or angle. So we deal with two unit in angle. One is radian, one is degree. Okay, one is radian, one is degree. So you still remember what you learned in your mathematics? 2 pi, yeah? So this is an important equation. Okay, and try to understand in the following class when we use degree, when we use radian. There is a certain case we need to use radian. In certain case we need to use degree. So this is the, if you have most of the time we deal with radian. So if you have small angle in radian, we will use this definition, which is the S equal to R theta in mathematics. So in my slides, I use C to represent the circumference of that section. So or in normal case, because we learn statics, we learn about how far it travels. So we'll use S as a distance or circumference. But you can use C as long as you label clearly in your answer. Because the first thing you answer, after you read the question, the first thing you need to do is draw something. So that is the second steps. So when draw something, make sure you label clearly your diagram. So this one is just a revision to get radian if you're given the circumference of or distance from the center. Okay, so this one is your another formula, 2 pi equal to 360 degree, right? Just a revision. So this is just a cheat code. With most of the time, if you have an easy case, you have a 90 degree, you have a 360, you have a 360, then it become 2 pi radian. Okay. Of course, this one you will see in the mathematics. Most of the time, you need to convert degree into radian in your solution. So this is just a very simple equation, and don't assume that most question you will see 90 degree. Because in engineering statics, we will give you application of what you learned in mathematics. Okay, so this is an example. 12 degree equal to how many radian? So you just pull this one to here, pull this one 2 pi, pull 360 here. So you want to find 12, right? So multiply 12 lah. Okay. So you want to know 1 degree equal to how many radian? You just pull 360 to the correct side. So here, 1 degree equal to 2 pi divided by 360. So if the question give you 12 degree, you just multiply by the factor. Okay. So this one should be, and then your answer again is three significant figures. If 3 significant figures or 3 decimal place, so most of the time, again, 0.209, 3 decimal place or 3 significant figures. 3 significant figures, sometimes you will see 1.29, 10 power 3 something. Yeah, that. Okay. This is a reminder lah. So recall what you learned in your trigonometries. If you see a right angle triangular, most of the time we try to understand the problems or the question in this form, or we try to break into right angled triangular. If you cannot see right angled triangular, then we use another formula. So this one, if you see a right angled triangular, you need to recall the trigonometry equation, which is your tangent sine cos. You should already know how to find this one. So most students, they have careless mistakes. It's not that they don't know, but they have a careless mistakes in finding tangent, cos, sine. All right. So in statics, question, we won't give you flat surface in most of the time. You won't see flat object, means on flat, this one. You will see something moving at the slope. So this is application where you need to use this one. Okay. So sine, cos, tangent. Sine equal to opposite, right? It depends how you remember. I remember by the eye, means I from where. This is the angle I want to find. So my eyes is here. So sine is opposite and hypotenuse. Of course, you have to remember where is your 90 degree. So eyes, size of your eyes is opposite and hypotenuse. Cos is B divided by A. Cos means two sides. Tangent, opposite and side. So try to make good friend with this one. Important. And this is an area of careless mistakes in most of the time. You understand the question, but when it comes to this angle, let's say you want to find the magnitude of this one and this one, you confuse. This one maybe now you see this one very clear. You cannot do this one. But if the question feed you with a lot of information or give you a very complex diagram, for example, a Grab driver with something, your brain will try to play game with you. Right? So seeing that this one. Okay. Now again, this sine, cos, tangent, they are in degree unit. If the question you need to answer in radian, then you need to use Taylor series. Have you heard about Taylor series? Yeah. So of course we don't in statics, we won't ask you to write this one. Just a recall of knowledge. This Taylor series only when it comes to radian unit. So when it comes to radian unit, if the angle is very, very small, means this one very, very small, then you can cancel the back here. Because if the angle is very small, you multiply 3 times, become even smaller, near to 0. This one also, this one also, this one also. So we can simplify these two, become sine theta equal to theta. This one is radian, means your angle is in radian. Then cos theta equal very near to 1 if the angle is less than 1 radian. This is the the thing that you need to remember. If the angle is less than 1 radian, or the question give you hints, it say assume angle less than, you see 2 arrow means you assume the angle very, very small or smaller than 1 radian, then you expect you use this formula. Okay. Right. So same with other things. This is a small approximation. It's just a revision, just a revision. So if the angle, again, this one is in a radian dimension. Don't confuse this slide with the previous one. This one, if you see this approximate one, any equation that approximate one, usually they are in radian unit. You see the question in the radian dimension. Not in the degree. Not in the normal degree. Normal degree one, you make friends with sine, cos, tangent. Outside sine, cos, tangent is radian. Okay, so this one you learn in your mathematics. So this is a revision. So if this one is in radian unit and it's very small, how small it is, less than 1 radian, then you can use approximate straight away. This one is radian unit, means the angle in radian unit will be approximate by C divided by A. B will be same as A. B will be same as A, means this length will be same as B, because this one very, very small. So this one will come down like this, right? This length will come down, A will come down like that. So it will very, very near to B. If this one in radian, very, very small, less than 1 radian. Okay, then theta also, you can get C and A. This one, theta, also you can take this one divided by A. Divided by B. So there are two calculations. So approximate. If you use this set, then A will very near to B. If you use this set, then the angle will be very small. Okay. So this will be a chart for you. You don't need to remember lah. You just need to know the approximate method and the actual value. There is an error there. For example, 5 degree, right? So 5 degree, how you find 5 degree in radian? So again, you use 360 equal to 2 pi radian. 1 degree equal to 2 pi divided by 360. So you take this 5 degree, you press your calculator, 5 degree multiply 2 pi divided by 360. You will get 0.087 something in radian unit. Then just now in approximate method how to approximate method means this sine degree equal to 0.287 8727. This approximate method means this sine radian equal to radian. Okay, sine theta, this one is in angle, means sine angle degree. If you use approximate method, sine theta equal or very near to theta radian. So theta radian is what? This one. Okay. So if you use approximate, this sine theta degree equal to this radian. How to get this one? How to get exact value? How to get 0.087156? You use your calculator, press sine 5 degree, you get this one. Means if you have a right angled triangular, you press calculator, sine 5 degree, you get this one. Then the error will be 0.1%. You know how to find error, right? Take something, divide by. Okay. So you take this one minus this one divided by this one. You multiply 100, you get 0.1%. Apply the same for the rest. Okay. So as the degree increase, approximate method will give you more and more error. So what does this table tell you? This one is important for your, especially when it comes to your lab experiment. When you see data, then you need to understand why there's an error between your calculation and between theory and the one that you collect in the lab. So if you approximate, the larger the angle, the larger the error. So that's why in the earlier slides, when we talk about small angle approximate, it have to be very smaller than 1 radian. Okay, so 3.5 still okay lah, but if you talk about aerospace, you talk about astrophysics, then this one is a lot lah. But for normal application, 3.5% still very low. Okay, so this one is extra information. All right, now we need to talk about how to use the unit. So this is just a calibration briefing, because some of you might carry some bad habit from other module. So this is just a reminder, especially when you use prefix and multiplication. So for example, Newton is force. So what is force in the second Newton law? F equal to ma. So what is m? Unit, kilogram. What is acceleration unit? Meter over second square. Right? So F equal to ma. Then you can write in this form or in this form. So this divide by s square, you can write in -2. Something like this. And then we will use dot to separate the unit to avoid confuse. Right? So this is like you bracket this one, kilogram dot meter second square. But of course, as you go deeper and deeper, you become more and more expert. We don't expect you to use dot anymore. It's just that it's just a practice so that you know you do not confuse with the units. Because as you go more and more deeper, you involve with so many units, so many parameters. Then in your writings, sometimes you are confused with the units, especially m here. M, if you write too fast, sometimes some of you might confuse with the mass. F equal to m, you might confuse the mass if you not write properly. Okay. So there is a difference between m dot s and ms. This is just a reminder lah. Just a reminder. Of course, in earlier stages of statics, we will stress about dot. But as you go deeper and deeper, when you go engineering dynamics, we no longer use dot lah. So it's just that there is a dot there, but we try to skip the notation of dot. But there is a difference between m dot s and ms. So they are not same. They look same, but they're not same. Okay, what does it mean? The first one, if you use a dot, it means meter second. If it's used ms, it means millisecond. Because prefix, kilogram, megagram, and so on. So this is just to avoid confusion between unit and prefix. Okay. So in the following slides, you will see sometimes I use dot, sometimes I don't use dot. But I expect you to know which one is prefix, which one is unit. Yeah. So this is just a reminder lah. Just a reminder. Another one is exponential power. Exponential. So if you write this is micron 10 power -6, right? So if you write micron n square, for my dimension, when you mark your answer, it means you are actually meaning micron Newton bracket square. It means the whole thing, you square the whole thing. So these are the something lah you need to take note lah. Because some of you you have all this bad habit. You assume when every time you write square, is this one square only, but not. If you talk about unit, these two combined together means you need to multiply 2 times. So these are the when it comes to especially when it comes to static and dynamics. Okay. Yes, a bracket, or you can just there's a certain way later I will discuss lah. So either use bracket or straight away. Yeah. You can use dot if you want. Yeah, you can use dot. Right. So another presentation is this one. Okay. So again, this is just a reminder because I've seen careless mistakes here. So write properly. Don't repeat lah. This one. So this one, if you write means n square in my dimension, you meaning this one and this one. Right. So again, square also same. It means you need to multiply millimeter 2 times. Yeah. Same concept lah. If you understand, then it should be good. Right. Then the next one is okay. Some bad habit. Of course, sometimes my slide also appear like this because I want to save space. I just write like that. So good habit. Okay. Newton over mm. As a starting point, we always encourage you to write in unit SI. So length unit SI is not mm, it's in meter. Right. So we will prefer to write in Newton and meter, and with the prefix, correct prefix. Of course, some question they'll force you to continue to use Newton over mm. It's just that to make a good habit in answering question, try to convert your unit into unit SI and carry with the correct prefix. So this is just a early revision reminder lah. So try, if you have this bad habit, then try to have a good habit to apply in your answer. Okay, so another one, yeah, for example, meter over milligram. So we want to put in kilogram. So convert milligram into kilogram, then do the correction in the prefix. Okay. The next one is just a power of 10. So you can convert the prefix into index, right? Power of 10. So kilo into, most of the time our answer will be in this form rather than we write the prefix alone. So we'll convert kilo into bracket 10 power 3, carry along the unit, and 60, this is nano is 10 negative 9. And if you are weak in multiplication of index or multiplication of power something, you need to do your homework lah. Go back to your mathematics and do homework. So this one multiply by this one is plus. So 3 plus minus 9 is minus 6. Right? Then you readjust the thing. So this one becomes 3000, actually 10 power 3. 10 power 3 plus minus 6 is minus 3. So you get this one. Right? So 10 power minus 3 Newton dot meter. If you remain your answer at this one, also correct. Most of the time, your final answer, if you write like this, also correct. Or you can write in this form, also correct. But it's okay, you stop at here. Most of the time lah. Okay. Yeah.
Three, and then Philip, then like you open brackets, then you write n of m. That's allowed.
This one.
Like between like
M bracket like that.
Yeah.
It means something else. So don't bracket the wrong thing lah. Okay. Yeah, it means something else. If you bracket this one, means you already milli then milli mm already. If you bracket bracket means you multiply Okay, so is try to separate the unit and prefix. Don't confuse the unit and the prefix. Right. All right. So these are the few careless mistakes that you need to take note. Another thing is something is important. For example, this one, dimensional homogeneous significant figure round off calculation. So this is in your calculation. So try to adopt all these things. What I mean by dimension homogeneous? It means that try to put them in the correct dimension. So for example, later you see this equation, right? S equal to Vt plus so and so. You learn this one in your physics projectile. S equal to Vt plus this one. So before you solve, make sure you put in the correct dimension. For example, your distance should be in meter when you do calculation. Velocity should be in meter per second. Because why? Why we mention this one? Sometimes when we set question, we don't give you the direct dimension. We give you kilometer per hour. So when you do this question, you apply this equation, you need to convert your velocity into meter per second. Don't straight away substitute the kilometer per hour value here. Convert into correct unit first before you solve. So time is second. Sometimes it give you hours. So you need to convert hours into second first to solve this equation. This mean homogeneous lah. Dimension homogeneous. Same with the rest lah. Same with the rest. Okay. So when you cancel the dimension, you arrive at meter. This is called dimensionless analysis. Okay. So this is called a dimensional homogeneous. Mean make sure when you solve problems, when you write the equation, make sure the one that the value that you use for substitution, you already converted into the correct unit SI. That is a reminder lah. Because some of it you know how to do, but your careless mistake is you straight away substitute the value. Then wrong idea. The question give you kilometer per hour. You straight away you substitute the kilometer per hour value here. So wrong. Right? Significant figure, you know lah. In this case, you need to use three significant figures. Right? Round off, round off less than 5, you become 0. More than 5, you add 1. Okay. Something like that. This one you read lah. Okay, calculation. Again, just a reminder, use 3 decimal place or 3 significant figures. Right? It depends on the final answer. So final answer, if your final answer is maybe 2 something, the value is 2 meter per second. So you can write 2.00 meter per second, at least 3 significant figures or 3 decimal place. Depends on the answer. Okay, the objective of this one or the purpose of asking 3 decimal place is for accuracy. Accuracy. For example, gravitational acceleration, we will ask you to use 9.81 meter per second rather than 10. Don't use 10. Okay, don't use 10 for gravitational acceleration. Okay. If in SPM or secondary school tests, you use 10, you're still correct. But when come to university level, use a higher accuracy value. Right? Okay. General procedures to solve problem. This one, you will practice this one from time to time. You read question. Read the question. Identify this question from chapter, which chapter? Chapter 1, chapter 2, chapter 3. Each chapter has their own formula. Right? Then after that, first step or first section of the question or section A usually asks you to draw something. We call it free body diagram in this this one. So you need to draw a diagram. If you start by equation, it's not wrong, but you will miss out something. So for engineering dynamics and statics, you will always start with the diagram. We call it free body diagram later, but diagram. Then you apply equation in this module, or for dynamics also. After you draw diagram, write the general equation. For example, you write F equal to MA. It will give you 1 point, 1 marks for that, for all the general equation you use. So usually in one question out of 25, minimum marks for this general equation will be 4 marks minimum. Means 4 equation you need to use or solve the equation. Even you write V equal to ds dt, also 1 marks. Don't straight away substitute value there. So general equation is important in this module. Then you solve lah. This one is the careless mistakes that we mentioned just now. You use the wrong unit. You don't know how to multiply the prefix, the indexes. You don't know how to do. You don't know how to do cosine. You confuse with radian, degree. That one. Here, this is the careless mistakes that kill you lah in the test and final exam. So these are the things that you need to take note now. Then if you're able to do the first 4, then this one, you need to check your answer. So for engineering statics, you need to think after you solve your question, you get positive value, what does it mean? If you get negative value, what does it mean? It means something. So for example, you look at vector. Later you see. So in general, all the direction to the right is positive, to the left is negative, go up positive, go down negative. So if the final answer, let's say final answer, you get velocity equal to minus 10 meter per second. It means it's go opposite direction. It can go to the left, it can go up, but it's not to the general axis. Okay, general axis, x positive, go to the right, y positive, go up in general. But as we go deeper and deeper, I will ask you to flip this, put this one according to the surface. As we go deeper, but in now, just stick to this one first. Later, I will teach you to put this traditional axis into the surface. This is just nothing. Okay, so example 1, ask you to convert 100 kilometer per hour into this one. So can you do? What is the answer for 100 kilometer per hour into meter per second? What's the answer? It's just a quick one. Just a quick one, right? What? 37 what? 37.78. Anyone get the same one? 37 something? Is it 37 something? Yeah. Okay. So you change the prefix first. Kilo into 10 power 3 hours. 1 hour equal to 360. 27.8 meter per second. Okay. So another set of answer also correct. It's a long, lengthy way in the mathematics sense of solution. You use bracket 1000 meter divided by 1 kilometer. This is a lengthy way. This is my shortest way lah. Both give you correct answer. So you convert 1 hour into 360. This is how you write in mathematics. Okay, you want to convert kilometer into meter, means 1,000 over 1 kilogram, 1 kilometer. Want to convert hours, is 1 hour divide 360. If you're not good in this, straight away use prefix method. Both give you correct answer. Okay, then you cancel the unit. At the end, you arrive at meter per second. It depends lah, which one you familiar with. I will propose the first method lah, but this is a textbook method. If you want to know the long way, okay. So same, the second one also same. If you want to convert 24 meter per second into kilometer per hour, so how you convert? How you convert meter into kilometer? 1 meter equal to how many? Okay, 1 kilometer equal to 1,000 meter, right? So 1 meter equal to how many kilometer? 1 10 minus 3 kilometer. You understand, right? Who cannot get this one, you need to work in your mathematics. So straight away, I give you this one. So 10 minus 3 kilometer. Then second, you need to 1 over 360 become hours. So the answer is 86.4. You can do the long way also. This is a long way. Okay. You can choose which method you think comfortable. But I would highly recommend to start using this method because it will solve the question faster. Only you need to be careful on the unit that you convert. Okay, density, this one another exercise. Convert density gram over cm cube into kilogram over meter cube. Can you convert? Same. If you don't know, you just write something like this: 1 kilogram equal 1,000 gram. Again, cm cube is what? You multiply 3 times. The cm 3 times. So 1 cm equal to how many meter? Sorry, 1 meter equal to 100 meter, 100 cm. But you need to convert back. Okay, so what is the answer? Wong Bingyi, yep, Ziyi not here. Which is another piece of attendance? Okay. Okay. What's the answer? What answer you get? The question asks you in kilogram over meter cube. What answer you get? How many you get? Second half, we start to look into vector already. Second half. First half, just to warm up your brain a little bit. What's your answer for this one? Is the answer? You don't know? How come you don't know? You have to have confidence. What answer you get? You understand the previous slides, right? That's the application of what. So what answer you get? Huh? You don't think is correct. So what answer you get? Okay. Looks correct. Okay, so again, here I'll show you the answer lah. Okay. Gram into kilogram. How you write? 10 power what? -3 kilogram. cm cube. You bracket this one. So this one cm is what? 10 power how many? Minus 10 power -2 power 3, so it's -6. So you solve the top and bottom, something like this. So you write bracket, then this one -6, this one -3. So you know that if you take above and this one is minus, so this one divide is minus. So -3 minus -6, you get +6. So -3 positive +6, you get 3. Okay. So I start to use dot lah to just separate. If you don't use the dot, also correct. It's just that just to separate the things. So the final answer is 3.85 10 power 3 kilogram over meter cube. Okay, wrong answer here. It's not 2, it's 3. So sometimes in the test or final exam, if you accidentally write something like this, I will circle this one. It depends. Sometimes I give you pass, sometimes I will just minus marks here. Because there are some marks for calculation. So if you write something like this, I will circle this one and then I wait and see whether I can help you or not. If it's 1 mark for the steps, something like this, you will miss the 1 mark for steps. Can also. In the way of processing, you can skip writing the units. Steps. Step, yes. For example, you need to write something like this. Without the unit also, I give you correct. Okay. So important is the final answer. Okay. This is the long, yeah. Okay. All right. So this one, I think I'll just give you as a homework. Go and see this one. All the answer is on the slides, right? So it just this is just playing with the milli, giga, mm. This one is mathematics question. All right. So we have a short break. Maybe go a little bit more. Now it's 8:50. So all the answer is here. This is your homework. Go and do and see the. I go very fast. Okay. So these are the extra homework. If you want to do, you do. If you don't want to do, it also can. Okay, so you do, then if you want me to check for you, you just send it to me. Then I mark for you during my free time. Okay, I don't show the answer here. So if you want to help to check your answer, also can. So all these are extra homeworks for you. So there are more than 10 questions here. So just extra homeworks. So again, in Canvas, I already upload the version 2 tutorial question for chapter 1. It's quite complete. So you can download and either can print out or you can use your tablets to write something on the tutorial question. Again, tutorial question, that one is just learning tools for you. You can use, or if you choose not to use, it also can. Right? You don't need to pass up to me. Just that one is just for you. Okay, so we will continue 9 o'clock, right? Maybe 9 minutes breaks. Then we go into vector already. Oh yeah, 1 hour only. Hey, I forget it. Okay, we stop at here. Our next class will be next week already. Okay. Yeah. Later I will upload into this one. You will see the yesterday one in the canvas already. The recording also inside the canvas already.